Now we will discuss the important concepts of limits, continuity and differentiability. Before that, we will take an important example which gives the insight about the concept of limits, continuity and differentiability, and then we'll give the formal definition. The example is of modulus function. It is one of the very important function. We write this function fx as mod x, that means x within two vertical bars, and by definition we can write mod x equal to x if x is greater than equal to 0, that means if x is 0 or positive, and it is equal to minus x if x is negative, that is x is less than 0. This is the definition of the modulus function. We have to remember this definition and it will be helpful to solve many of the problems. Now, if we draw the graph of this function, the graph of any of the function, if we are able to draw, it will help to solve the problem very easily. The graph of the modulus function is, we take two mutually perpendicular axes, this is x and y. Y represents the function of x, and graph will be shown here. This point is x equal to 0. Alternatively, we can also draw the graph by transformation. For this, first we have to draw the graph fx equal to x, which will be drawn here. It is a straight line which passes through the origin and incline at an angle of 45 degrees with the positive x-axis. And then to take the modulus x, we have to remove this left hand side portion and we'll take the image, mirror image of the graph about the y-axis. So this will give the graph as, this is the actually remaining graph, and then we will take the mirror image about the y-axis. So mirror image will be here. So this is the y equal to mod x. This is the modulus function. Now we will find the limit of the modulus function. As we have defined that modulus function y is equal to mod x and its value is x if x is greater than equal to 0, and its value is minus x if x is less than 0. And graph for the modulus function is drawn here. It is xy and shape of the graph is here. The point is x equal to 0 where we have to find the limit. So limit of a function, say fx at point, say x equal to a. Suppose this is some graph and this is the point a. This function is fx, and one of the point which is just before this a, this point is a minus h where h tends to 0, and on the right side there is another point which is say a plus h where h is tending to 0. So we have to define left hand limit as limit, this is the limiting value tending h tends to 0, f point a minus h. This is called left hand limit. That means value of the function fx at a point just before the point a from the left hand side. And right hand limit is defined as the limit h tends to 0, f a plus h. This is the value of the function for a point just right of the point a. So f a minus h is the value here, and f a plus h is the value just right of the x equal to a. And a limit of a function exists by definition. Limit of function exists if left hand limit equal to right hand limit, irrespective of the value of the function at point a. That means if limit h tends to 0 f a minus h, which is the left hand limit, is equal to limit h tends to 0 f a plus h, we say limit exists at the point x equal to a. By this definition of the limit of a function, we will find the limit of the modulus function, which is given as y equal to mod x, and it is equal to x if x is greater than equal to 0 and minus x if x is less than 0. So left hand limit at x equal to 0 will be equal to limit h tends to 0 f 0 minus h. It will be equal to, now we have to be very careful that this 0 minus h is the value which is less than 0, and for this value we have to go in definition of the modulus function where x less than 0. So we will put the value 0 minus h in place of x because this y is fx. So we will replace this x by 0 minus h. So in definition we will replace this x by 0 minus h. So we will get the value as limit h tends to 0. We have just to replace this x by 0 minus h. So before minus and then 0 minus h. It will give limit h tends to 0, then h, and now substituting the value of h, it will be 0. So left hand limit of the modulus function is 0. Similarly, we have to find the right hand limit at x equal to 0. This will be equal to limit h tends to 0 and f 0 plus h. This will be equal to limit h tends to 0. Now we have to see that this 0 plus h is greater than 0. And for this greater than 0, in definition of modulus function, this lie in the branch which is x greater than equal to 0, which has the definition x. So we have to replace this x by h. So we will get the value, that is, it is h. So it will give, this is 0 plus h, so it will give limit h tends to 0 to h, and substituting the value of h equal to 0, we get the value 0. So left hand limit is equal to right hand limit, which is the 0. So we say limit exists and limiting value of function fx equal to mod x, which is the modulus function, at x equal to 0 is 0.